It's 2-6. We've solved quadratic equations. The fastest way to solve something when it's in this form is to factor and set it equal to 0 and use the zero product property. But unfortunately, that only works when our answers are integers, like 1 and -5 or 6 and 7. It doesn't work if they're not. And so yesterday you solved by completing the square. And that's actually always what you have to do. That is actually the only choice when you can't factor, is to complete the square, which was an involved process. You moved the constant to the other side, you added half the middle coefficient and squared it, you factored, and then you took the square root. If you do that process with this equation, which we can do later, it takes a page to do. If you solve for x and complete the square, you will get this. You will get x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And there are a couple of songs, Pop Goes the Weasel and something else I'll play for you that help you memorize it, but you do need to memorize it. And in fact, even if you can factor something and you get integers for your answers, you can still use this. In fact, this always works. The disadvantage to using it is you have to do this arithmetic really carefully, and it takes a number of steps. It takes longer than factoring. That's the disadvantage. So you don't want to use it unless you have to. So we're going to do 3 different examples of using this. One of them, and this right here underneath the radical, this part underneath the radical is called, does anyone know what that's the name for just this part, b squared minus 4ac? It's called the discriminant. Yeah, discriminant. And that part, sometimes a question will just say, evaluate that to tell me how many answers you have, because we're used to getting 2 solutions usually if this is just a positive number. So if under the radical it's positive, you'll get 2 solutions, 2 real solutions, and we'll do an example like that in a second. If that number under the radical turns out to be 0, how many solutions do you think you get? You only get 1, because this plus or minus doesn't really change anything when you're adding or subtracting 0. So if this discriminant evaluates to 0, we'll do an example like that. You get 1 real solution. And what about if it's a negative number under a radical? No real solutions. Yeah. So we would say 0 real solutions. We can still write an answer, but they're going to be imaginary, and I'll show you that. So that's the piece that maybe you might not have gone into as much in Algebra 1, but you definitely did the quadratic formula. So 3 examples. Number one is, I want to solve for x squared minus 5x minus 7 equals 0. So let's say you're naively going along trying to factor this, and you're trying to figure out what multiplies to -7 and adds to -5. Anything? There's nothing. So you could complete the square like you practiced yesterday. It would be a little ugly though, because half of this is 5/2, and then you'd square a fraction and you get 25/4, and it would really be ugly. This is easier. So let's define a, b, and c. A equals what? It's actually the number in front of x squared, which is 1. Yep. B equals, yep. And c equals, yes. So we have to just carefully plug those numbers into this formula and simplify, and we'll have it. So what I'm going to do is, I'm going to do the b squared minus 4ac part first, and then we'll just, so that I break it into pieces, and then we'll easily do the rest. So the b squared minus 4ac, just do that part. That's the part that everyone messes up, believe it or not. It's just order of operations, but everyone misses it. all you have to do is square b and then subtract 4 times a times c. I'll just show you why it's easy to mess up. First of all, when you square b, you have to put it in parentheses. In fact, you need to put everything in parentheses when you plug it in. This gets people right here. The negative times a negative is a positive. That's the part that gets everyone. I'm just telling you ahead of time. So negative 5 squared is 25. That's not a problem. But this should be plus 28, not minus 28. Because negative 4 times 1 is negative 4 times negative 7 is plus 28. So because it's a positive number, I already know that there's two solutions, because that might be all the question's asking. And now let's figure out what those answers are. And you will need a calculator. If you don't have one, you can check one out in a second. So let's figure out what those answers are. X equals negative b. The opposite of b is positive 5. I'll just show the work here. Plus or minus the square root of 53, because we just evaluated that, all over 2 times a. So it's 5 plus or minus the square root of 53 over 2. That's hard to tell what that means, so we need to plug it in on our calculator. One answer is 5 plus the square root of 53 over 2. The other answer is 5 minus the square root of 53 over 2, and we really just need to do that on our calculator. So if I type in 5 plus 53 square root equals divided by 2, I get 6.1. Yep. Oh yes. I would never ask you to evaluate this without a calculator. And this is negative 1.1. And that makes, that I could, those are the x-intercepts. If this were a graph of a parabola, it would cross the x-axis at y equal at 6.1 and negative 1.1. So let's try one where we have no real solutions. So that was the first example. Let's try this one. X squared minus 6x plus 10 equals 0. So hopefully we've got it memorized now. So A equals 1, B equals, and C equals. You don't have to write out the list of these as long as you do it correctly. So B squared minus 4AC. B squared minus 4AC is going to give us 36. And is it plus or minus 40? Minus 40. So that gives us what does that give us? A negative number. Okay, so right now, based on the discriminant, that means there's going to be no real solutions, because you can't take the square root of negative 4. But that doesn't mean we still can't answer it. So we would say, now we're going to use the formula x equals negative b plus or minus the square root of negative 4 all over 2a. So opposite of negative 6 is positive 6. Now let's do plus or minus. 2 times 1 is just 2. So let me tell you, this might be new to you. When you have a negative number under the radical, there's this definition, there's this imaginary number called I, and we'll practice with it on a different day. But the square root of negative 4 is I times, is basically 2I, and I will explain why later. So this simplifies to 3 plus or minus I. And they're imaginary solutions. What does that mean graphically? If this were an equation y equals this, and you graphed it, what does no solutions mean graphically? Where does, yeah, Yotam? It's a parabola that doesn't cross the x-axis. Can you picture that? Looks like this. So anything like this, right? See how it never crosses the x-axis? That's why you're not getting any answers. And that's fine. One more example where we get one solution. One last example. And then you'll have every type. And then you can rewatch this as many times as you like. So 16x squared. And if you're in a bind and I don't tell you what method to use to solve something, you can use this if you're good at it, if you like it and you do it well. But I caution you, you have to do b squared minus 4ac carefully. That's why I'm doing it as a separate step. So b squared is negative 40 squared minus 4 times a times c. What do you think you're going to get here?
Positive.
Well, we already did one where we got a positive. Yeah, we're going to get 0 because that's the case I haven't done yet. So this is 1600 minus 1600, or 0. And I'll show you how that only gives us one solution. Can you picture, and what does that look like? A parabola that crosses the x-axis once? It might look something like this. Right? Graphically, there's your one solution. It's the x-intercept. When you solve this, it's the x-intercept. So let's do x equals negative b plus or minus the square root of 0. That means nothing, right?
1.
No, square root of 0 is 0.
Oh.
Yeah. So over 2a. And so you basically get 40 over 32. And that's where it crosses the x-axis. That's 20 over 16 or 10 over 8 or 5 over 4, 5/4. And it's easier to get a decimal answer. So 0.7. So it would be over here somewhere, and it would open up. In this case, it's going to look like this. And at 0.7 is where it crosses the x-axis.